Okay, more factoring. Example 2, these are examples of common factors and then simple trinomial factors. So remember how I said you always have to check for a GCF? Well, in this case, there is a GCF that comes out. So I can divide this whole thing by 3 and go 3x squared plus 2x minus 15. Then I check for dots. There are 3 terms here. It's not going to be dots. Then I check for a simple trinomial factor, an STF. 3x and x. 2 numbers that multiply to negative 15 and add to 2. I look at my factor chart. Factors are 3 and 5. They're going to multiply to negative 15. Positive 5 and negative 3 add to 2. Now I am done. Let's do it again. Check for a GCF. I can divide out a 2. I can't take an m out because there's no m here. M squared plus 9m plus 14. M. Square root of, 2 numbers that multiply to 14 and add up to 9. Positive, positive, positive 2, positive 7. Again, you're looking at your factor chart. Your factor chart's going to say 1 and 14, 2 and 7. Those are your only factors of 14. It's got to be 2 and 7. Well, remember that factor chart I'm talking about is this right here. Here it is right here, right there, 14. You have that as a reference. Let's do this again. I can divide out a 4. Aren't I lucky? 4a squared minus 3a minus. How many times does 4 go into 72? It goes in 18 times. You might want to use your calculator for that. Now I check for a simple trinomial factor. I put my a here and a here. I'm multiplying to a negative, so I know one's going to be negative, one's going to be positive. 2 numbers that multiply to 18 and add to negative 3. They're going to be negative 6 and positive 3. Factors of 18, again, remember those are 1 and 18, 2 and 9, and 3 and 6. 3 and 6 have a difference of 3. So 2 numbers multiplying to 18 and adding to negative 3, negative 6, positive 3. One more time. 5x squared minus x, because we divided out a 5, minus 20. So I'm dividing out, I'm factoring out a 5. I can write that 5 there if you want. You don't have to write that, really. Simple trinomial factor. I want 2 numbers that multiply to negative 20. So it's going to be positive and a negative, and add to negative 1. Remember that there's a 1 there. What 2 numbers have a difference of 1 and add to and multiply to negative 20? 4 and 5. Check your factor chart if you're unsure. But positive 4, I almost made a mistake there, and negative 5. Because negative 5 plus 4 gives me negative 1, and 4 times negative 5 is negative 20. And that is how we do our STFs to go with our common factors. Okay, moving on. I have a chart. If you like flowcharts and you want to know what to do, first step, common factor. Here's an example. Second step, how many terms are there? If there are 2, we look for a difference of squares. That's our dots. So this little bit here is the coefficient of the squared term of 1. So if we have 2 terms, we look for dots. If we have 3 terms, we look for our simple trinomial factor. Is the coefficient of the squared term of 1? In other words, is the is the number beside the first term a 1. It's always going to be in grade 11 college. So to be real, what it's asking is there a 1 right here? The answer is always yes. So we don't even really need to worry about this. Okay, so don't worry. Just go straight to STF. Look for those two numbers that multiply to 12, because we're not doing the box method. And actually, you don't learn that in grade 12. It's not part of the grade 12 college curriculum anymore. We don't worry about those harder factoring methods. So that's great news. So this is as hard as it gets for factoring. Don't worry. We are STFing. So those are our steps. And then we check, can it be reduced any further? Sometimes people forget, okay? And what happens is they forget how to do things, and they factor things out, and you factor out a 2 and you could have factored out a 4, and when you look back at it, you realize, oh, I could have taken out a bigger number. That's all I'm looking for you to do. So this is a flow chart to help you out, and I'm going to be saving this note and uploading the final thing. All right, couple more examples. This is a mixed bag of examples. Let's see. Honestly, if you pause now, take a break, I'm going to keep rolling, and I'm going to rip through these as quickly as I can. Okay, so factoring out, I'm going to take out a 9 because a 9 goes into 36 and 81. So 9 leaves me with 4w squared and negative 9. Then I see two terms. So now, and this is an example, I'm doing this one specifically because now I'm going to do a difference of two squares. 2w minus, because I've got two terms separate by a minus sign, and they're both perfect squares. So I know I'm going to have two identical brackets. 2w minus 3, 2w plus 3. Square root of 9 is 3, square root of 4 is 2. That's our dots, okay? Because it's two terms. Factor out a 3, I get x squared minus 4. I can do this again. Look, it's dots again. X minus 2, x plus 2. Again, dots. Why? Because there are two terms in there. This one right here, simple trinomial factor. Two numbers that multiply to negative 7. We know that we're going to have a positive and a negative, and add to negative 6. There's only two numbers that multiply to 7, 1 and 7. 1 plus negative 7 is negative 6. 1 times negative 7 is negative 7. Factor out a negative 5, j squared plus, careful on this one, minus. When I factor out a minus, I have to change this, and that's really important. Minus 7j. Now, I did this in 2 steps, and you could have done it in 1. Because I had a j and a j there, I can also factor out a j. So I can actually take out negative 5j from both of these and leave myself with j minus 7. This is a bit of an annoying one. Okay, this is one that I always put on the test, and it's kind of easy, but it's kind of hard because you have to recognize, hey, I can factor out a j. It looks a little like dots, but it's not. And you have to remember there's a j here and a j there, and that's where we go. That's our answer. All right. Factor out a 2. K squared minus 36. Again, 2k minus 6k plus 6. Factoring out a 3, x squared minus 3. We're done. We cannot factor further because 3 is not a perfect square. This is dots because 36 is a perfect square, but the square root of 3 is not a whole number. Right here, we've got a plus. We've got two terms. They're both perfect squares, but they're separated by a plus sign. So we cannot do dots. We're going to factor out 4w, and that is all we can do. 4w times w plus 4. Done. Factoring out a 5. N squared minus 8n minus 9. Now I've got two numbers that multiply to -9 and add to -8, -9 and -1. Two terms, separated by a minus sign, both perfect squares. Square root of 64 is 8 plus 1, 8y minus 1. Dots, boom, done. Same deal here. 5 minus x, 5 plus x. This one's a little bit tricky because you've got to pay attention that we're going to get a negative here. If you miss something like that, oh well, doesn't matter. Factoring out a 5, and I get x squared minus 4. Dots again, 5x plus 2x minus 2. Factoring out nothing, two numbers that multiply to -12 and add to 1, x plus 4, x minus 3. And we keep rolling. 6 more to go. Two numbers multiplying to 3 and adding to 4, a plus 3, a plus 1. Check for GCF. A, I can take a 3 out. X squared minus 7x plus 12. Check for dots. It's 3 terms. Check for simple STF. That's our example from up above there. Yeah, we can do that. Two numbers, careful on this one, that multiply to 12 and add to -7 are going to be a negative and a negative, because you can't add to a negative and multiply to a positive unless they're both negative. So we're going to have -3 and -4. This one here, 7d squared plus 7. We done. I factored out a 7. Difference of two squares, not a thing right here, but it's still factored because I was able to divide out a 7. 6 and 21. Can I take 6 out of 21? No. Can I take a y and a y out? Yes. Can I take another number out? Are there two numbers that go into 6 and 21? Yes. 3y. So I can take 3y out and get 2y plus 7. And that's factored. That's a callback to the very first thing. That's a GCF right there. All right. 2, I can take a 2 out because they're all even numbers. W squared plus 11w plus 30. Two numbers that multiply to 30 and add to 11. W plus 5, w plus 6. That's a 1, that's a -4. There's two terms, they're separated by a minus sign. They're both perfect squares, so they can go dots, z plus 2 and z minus 2. And here's the little secret at the end of the video. Dots is a useful shortcut, but it's actually just simple trinomial factoring, because if you think about it, 2 times -2 gives you -4, and 2 plus -2 gives you 0, and that is why there's no middle term. So on that bombshell, that's it. That's all the factoring you need to know. So you can pause this, rewatch this video, and tomorrow we'll take up the worksheet that goes with this. All right? Thank you for watching.